Uh, Today we are going to solve Leetcode 2179 count good triples in a array, and this is study questions in the daily contest, right? So let's start again. So hey everyone, welcome back to the channel, and today we are solving a Leetcode problem 2179 good counts of triplets in an array. And so it's a challenging medium hard level problem that involves permutations, ordering and optimizations using binary index trees. And so we will walk through the problems in the steps to understand the questions, building the intuitions, and then we'll go through the step-by-step solution. And so I'll teach you one by one in this problem statement. Okay, so let's understand first the problem, right? So here you have given two arrays, nums1 and nums2. As you can see here, we have given two array, nums1 and nums2, and having the length of n. Okay, so both sides having length n, and these are the two arrays. Okay, so first of all, it's a zero index array, 1D array, and having the name nums1 and nums2, and its length is n, right? So both of length arrays having length n. Gotcha? So each array is a permutations of 0, 1 till it will go to n minus 1. Means both of which are permutations of 0 to n. Means you can say each array is a permutations of 0, 1, 2 and so on till n minus 1. Gotcha? Now think. So what we want, right? So we want to count the number of good triplets. You can say xyz, right? As you can see here, right? We need three values, right? X, Y, and Z. So we want to count the number of good triplets, and the triplets means X, Y, Z. Okay. Now we'll think what is in the X, Y, and Z, right? So X, Y, Z are values from the arrays we will get from these two arrays, because we have given two arrays. So nums1 and nums2 was the two array that we have given of length, both have length n. So from there we have to find xyz, right? So xyz are the values from the arrays, okay, and their positions in the nums are increasing. So what increasing? So their position sorry, so these positions in the nums are increasing, like positions at x, right? You can say pos at x is should be less than pos at y. Means position of x should be less than position of y, and so position of y should be less than position of z, right? Like that we have to think. Okay, so it means we have given two arrays, nums1, nums2, and both sides are n, and each having the permutations of 0 to n minus 1, right? And we want to count the number of good triplets xyz, where xyz are values from the arrays. So their positions in the nums are increasingly, means like this, right? Means x positions at x should be less than position at y, and position at y should be less than position g, but the position of y should be greater than position of x. Gotcha? And position of y should be greater than both x and y, right? So means their positions in the nums1 are increasingly, right? And so positions in nums2 are also increasingly. Means if you count positions at 2, so all these values should be also increasingly. Means in the both array, their positions in the nums1 and nums2 should be increasingly. Means both should be increasingly, right? In the nums1 and the nums2 both, right? So let's go with one example, and what we have to do, and we have to return the total number of good triplets. Okay, we have to return that. Okay, now go through these examples, right? You pause this video and go through. Okay. Sorry. So let's continue. So we have given two nums, right? Nums1 and nums2 we have given, right? Two arrays we have given. And so the valid triplets are 0, 1 and 3. Because in nums1, the positions are 1, 2, 3, right? In the nums1 and nums2, right? In the nums1, they see the valid triplets will be what? 0, 1, 3. 0, 1 and 3. 0, 1 and you can take 3. 2 is not there because 2 is here in this array, right? So what we can say, there should be one element, right? So the values 0, 1, 3 is also increasingly in nums1 and 0, 1 and 3. We can remove from here too. We cannot remove, let it keep it, but the valid triplets both are in the same, right? So because nums1 and contains the position 1 to 3, nums1 position of this triplet is what? 0, 1, 2, 3, right? Or you can say, sorry, 0, 1, 3 positions are like, position means index 1 to 3. And in this, it is 1, 0, 1 and 3, 0, 1 and 3, right? So both are increasingly. And so the goal count was how many such triplets are there, right? So we had to find, and then we can say there are 4 triplets, right? 4 triplets of xyz such that these are the values are there. Out of those, only the triplets 0, 1, 3 satisfies these conditions, and so there is only one triplets, and that is what? That is called 0, 1, 3 having in both, right? In the common, you can see, right? There is only one triplets which is satisfying these things, right? So like that, we have to count how many such triplets are there. If all are there, means there are how many? 4 is there, right? So we can say 4 triplets. But there is no 4 triplets are there, where there is only one triplets, right? And so we are returning the output 1. I hope you understand these questions first of all. So the purpose of explaining these things till now is to understand the problem. If you not understand the problem, this become easy will become hard. If you understand the problem, hard will become easy, right? Now, what is the intuition to solve this problem, right? So you can go through the editorial section, it is given here. You can go through and you can read it. But first of all, before doing anything, you should understand the question that we have understand, right? Now pause this video and think how you are going to solve it. Do you have intuition, right? Can you solve it? If you want to solve it, then how will you do that, right? That you have to think, right? So let's reduce the problem to something easier to work with. So in the first step, what we should do, we will map each value to its index in the num2, right? So we have given num1 and num2, right? So what we will think, right? We should map each value of the num2, right? Or you can say we can map each value of its index in num2. Let's suppose the value 2 is where? At this position, at second position, right? 0, 1, 2, yes. And then we'll start with the 0. Its position is 0. 1 is at 1, right? Like that, we have to map each value to its index in the num2. So this will helps us to convert the problem into a single array transformations, okay? And in the next step, what we should do, we will replace each value in num1 with its corresponding position in num2. Got it? So first what we will do, we will map all these values in the nums2, right? Sorry, we will map each value of its index in nums2, right? And in the second step, what we will do, we will replace each value in nums1 with its corresponding position, which is in the num2. And let's call this as a mapped array, right? Like that we can do. So now the problem becomes count the number of increasing triplets in the mapped array. So question solved, from the 2 array, it will become 1 array. Means we have 0, 1, 2, 0, 1, 3 and another is 0, 1, 2, 3, right? Now these 2 array will become mapped array is what? 0, 2, 1, 3, right? So we will check in the num3, right? Not num3, you can say mapped array, right? So now the problem becomes count how many triplets I, j, k such that let's suppose I is less than j and j is less than k, and mapped at I should be less than mapped at j and should be less than mapped at k, means all these three elements are values in the mapped array. So this is a classic increasing triplet counts, and we can solve it by O of n log n. There is a algo, that is we can say FAANG trees or binary index tree. If you go here, you can search FAANG tree, right? So you go through this algorithm and you will understand this thing. Okay, coming back to this, so what we can say, we can solve this problem using the classical increasing triplet counts, and then we can solve in o n log n, right, using this FAANG tree method. Okay, or you can say binary index tree, we can also say binary index tree. So in the step wise, if you'll go, let me, okay, so first of all, we will do the first step. What we will do, we will replace it, right, and then we'll make a mapped array, right? So let's go with, this is the length of the array. If you'll find any of the length, you will get it. So this is a position array, we'll find, create, and then we'll put all this value. So what we will do, first of all, we'll build the position map from num2. So what we will do, we'll create a loop, and positions at element of 2 will assign the index, and so we will have this mapped array, position array, right? And then we'll create the mapped array. So we will transform nums1 to map the array using the position from the nums2, and so we will have mapped at I, will get the value of positions, right, and we'll store the value here. It's very easy. So these two things you have to do, right? Now what we will do, yes, now what we will do, we will initialize the bits, right, and then there is a FAANG left bits and FAANG right bits. Okay, so we'll create these two, and then we'll make a for loop, and we will do right bits, we'll update the value val and 1, and then we'll count the from the count we will get the count, and then we will return this count. And then in the step 4, we'll transform and we'll calculate the good triplets. So there is a for loop starting with the I is 0 to less than n, and I plus plus will do, and then we'll get of the mapped element with val all the elements. We'll remove the current from the right and we'll update it like this. So we'll have the left a smaller, right a smaller, so that we can do these things, and then we will do left a smaller into right a smaller will do, and then we'll get the count, and finally we'll add the left to the right, if like this, and then we'll say we'll return the count. Okay, so what we are doing actually, so in the solution part, you can say, so we'll build a position map from the nums2, right? What we'll do, we'll build the position, we will build the position map from map2, and so at the position at value, right, this value is nothing but the index of value in nums2, right? Gotcha. And then when we go for the building the mapped version of nums1, that is called mapped array, right? And so at this value we'll add the position at nums1 I, right? So we are transforming the nums1 to mapped array using the position from the nums2, right? In the step 3, we are using you can say 2 binary index tree, that is called FAANG trees, right? So the left bit counts will do how many elements are smaller than the current we have seen so far, right? So this is called left bit, right? Binary bit means binary indexed trees, right? So in the left side, we will store the count, how many elements smaller than the current we have so far, right? We have seen so far. And in the right one, we will store the count of how many elements are greater than the current we will see in the future, you can say, right? So like in the future, what we will see, that is, and in this, in the left side one, right? So the name says, right, left bits and right bits is bits means binary index trees, okay? And so we loop the for with the for loop, we'll find the right bits, we will update val, and then we'll pass 1, right? So we will update it, okay? Now we will do next, in the next step, what we will do, we'll do the traverse and count good triplets, right? So actually we are doing, we will traverse the mapped array, and for each index, right, for each index we'll remove the, you can say, mapped at I from the right index, and we'll count how many smaller elements are on the left to left smaller, right? So we are removing the current from the right one, and then we will, what we will do, we will find the smaller and greater, right? And then we will count you can say, how many smaller elements are on the left side, or how many are in the right side. So left smaller, right smaller, will get these things, and we will do multiply, right? And whatever will come, we'll keep counting in this one. So actually what we are doing, we will do you can say left smaller into right smaller to the total count we are doing here, and then finally we'll update the left bit with the mapped I, okay? So we are adding the current to the left, and this will efficiently count all the triplets of O log n, O of n log n, and so it will give you all the counts, right? So this is the code, guys, you have, and for the FAANG class that you can go through here also. Let me show you. Okay, let me expand it. Okay, so now you can see, so we have binary index class. So you have to create this class, right, so that you can store the n and the bits, right, that we have seen till now. So we are updating these things, right? So what we will do, these two attribute will be there, the bits, the bit and the array, and you can say n. So to initialize the this, we have to write the size of the array, will store here, like n plus 1 extra size we will take. And then to update the index and delta, you should have the index plus plus, and then if index is equal to less than equal to n, till that we will keep storing the value, and we will increase the index like this, and there will be a query. So if you find the query, you will have the sum, right, and this is the sum to calculate, and you will return the sum. So this is generic FAANG uh, class, right? Or you can say binary index tree class or FAANG trees. Let me know if you want in the depth to understand this. You can ping me in the comment. I'll create another video to explain each of this. I hope you understand this video, and this video will be helpful for you. So that's it for today. We have solved the Leetcode problem using smaller transformation and the FAANG trees. So in this video, what we have done, actually we have transformed to the mapped array using the bit, like binary index tree, to count increasing triplets, and we have get the result of O n log n times. So if you found this helpful, right, this video is helpful, don't forget to like, comment, any doubts, share your video with the DSA preparation group, and of course subscribe for more Java plus DSA content. So see you in the future, guys. Happy coding, and thank you. Bye.